Newton's third law. For every reaction there is an equal and opposite reaction. General movement requires an object to push off another. Such as when we walk, the foot pushes off the ground. When you throw a ball, your hand pushes the ball and the ball pushes your hand. The oar pushes the water, which in turn pushes the oar and thus the boat. Pushing or pulling involves you or your vehicle applying some force to an external object such as the floor. Let us say that the foot applied 10 newtons. The opposite force will be 10 newtons. However, there are other forces that cause movement that does not involve you or your vehicle pushing off an external object. Some examples are as follows: gravity, buoyancy, and pressure gradient force. Force equals mass times acceleration. Acceleration due to gravity is approximately 10 meters per second squared. Gravity applied on a 5 kilogram weight should be 50 newtons. So if you drop a 5 kilogram weight from your hand from a height, the opposite reaction on your hand would also be 50 newtons if Newton's third law is applied exactly the way it was in the previous slides regarding walking, throwing and rowing a boat. When you dropped the 5 kilogram object, did you feel the 50 newtons of force pushing back on your hand? Of course not. That's ridiculous. Buoyancy is an upward force exerted by a fluid that opposes the weight of an immersed object. The following equation states the buoyant force is equal to density times gravitational acceleration times the volume of fluid displaced. Let's say we have a jug of water which has a density of 1. Yes, water has the density of 1 kilograms per liter. Put a container full of air to the bottom of the jug. Container will move to the top. The volume of the container is 200 milliliters. Using the equation, the buoyancy force equation, we get approximately 2 newtons. Subtract the 1 newton of force due to gravity and you have a net force of 1 newton. 1 newton equates to 100 grams on the scale. Obviously there is no opposite force applied on the scale when the object was released. Similarly, a hot air balloon wouldn't move upwards if buoyancy force caused an equal and opposite reaction downwards. Pressure gradient force is the force which results when there is a difference in pressure across an area. The following is the equation to calculation the pressure gradient force based off difference in pressure and density. The driving force for wind is the pressure gradient force. When pressure is different from one location to another, a difference in pressure exists. Now if gas moves due to pressure gradient force calculated to be 10 newtons south, is there an opposite force applied of 10 newtons north? When wind blows on the back of your head, did the air in front of you push off your face when the air started to move away from you? Obviously not. As you saw in the video, the pressure gradient force was strong enough to lift the container, but that force is not seen on the scale. To lift the container, the air movement must apply a force greater than 1 newton. However, this is not seen on the scale. You can see that the scale never read above 100 grams or more than 1 newton. Additionally, free expansion of gas states that gas expanding into a vacuum does no work. How does exhaust from the rocket chamber move outside the rocket chamber? Does the rocket push the gas out like a person throwing a ball? Does gas move out due to gravity? Does the gas move out due to buoyancy? Does the gas move out due to pressure gradient force? A According to MIT, a rocket in its simplest form is a chamber enclosing a gas under pressure. A small opening at the one end of the chamber allows to escape. Pressurized gas escaping to low pressure sounds like pressure gradient force. The exhaust from the rocket chamber moves out of the rocket because of pressure gradient force. So what did we learn about pressure gradient force? There is no opposite force because Newton's third law cannot be applied exactly the way it was in the previous slides regarding walking, throwing and rowing a boat. Pressure gradient force come from potential energy just like gravity and buoyancy. The balloon car pushes off the atmosphere. If you put the vacuum hose near the opening of the balloon, the air moves into the hose without much resistance. When the vacuum hose is placed behind the car but away from the opening of the balloon, the air meets the resistance of the atmosphere causing thrust. In both cases the vacuum hose is behind the car to remove the motion, but it was drag that slowed down the car. As you can see, the balloon car didn't get to accelerate nearly as much when the vacuum hose was near the balloon opening. This first equation is how NASA says how rockets work. The second equation is the fluid dynamics equation for movement of a fluid through a pipe. Similarly, the rocket exhaust, which is a fluid, moves through the nozzle pipe. Both equations have velocity, so let us substitute velocity in the NASA equation with what velocity equals in the fluid dynamics equation. This is the equation you get after substitution. Mass flow rate is equal to density times volumetric flow rate. You can convert volume to mass with density. Volumetric flow rate equals mass flow rate divided by density. Now let us replace volumetric flow rate with mass flow rate divided by density. After substitution, you get 4 times the mass flow rate squared divided by pi, pipe diameter squared and density. There is no longer a need to calculate exit velocity. This states that mass flow rate is essentially force. This is incorrect. Get a vacuum cleaner and suck air from a pipe with only one end open but a small hole on the side of the pipe near the closed end. There is a mass flow rate exiting the pipe, but no force is applied to the pipe. The fluid dynamics equation is used in many industries, and the NASA equation is used by one or perhaps 2 industries that are mainly run by the state. So here we are faced with a direct contradiction of what observation and experiment tells us and what NASA and other institutions tell us. Why do people believe NASA? Perhaps they are allegedly the most prominent scientific community and have no other choice. Why do they lie? Like most people, lies are told to collect money. NASA collects taxpayer money. NASA is like the college student who uses his tuition money, which was obtained from the parents, to party and perhaps buy the girlfriend a new phone, instead of using the money to pay for school. The college student continues to lie to the parents about going to college.